Hello everyone. In this video, we will be discussing on the concept of stack. What is a stack? How the stack operates in 8085 microprocessor. So first of all, what is a stack? What is meant by a stack? And how a stack operates? How a stack operates? So what is a stack? A stack is a separate memory which is being used to store some amount of data. So this data, whenever we are either a programmer may send a value into the stack or automatically some offset addresses are being stored into the stack. So every processor requires a minimum amount of stack to be present in a microprocessor. Without stack, processor may not be complete. So stack plays a very crucial role in projecting or in terms of an architecture of any processor. So when you come to the stack, how it stores the data, how the data is being stored in a stack. In the stack, the data is stored such a way that, and say the first it is stored in the bottommost location, then about to that one, let's say this is the first location it has been stored, bottom of this stack. Then it goes to the second one, second one, second one, second one. Like that way, it will store it up upwards. It moves into the memory backwards. So when this data is being stored, and now this way is being closed like this way. So when we are retrieving a data, what it does is that it first it picks this one, then this, then this, then this. It will flow in the back. So here, whichever the data which is been in at the last is coming out at the first. So it will follow the procedure called as last in, first out. Whichever it is last in, this data is last in. First data is this one, second, third, like that way. At the last, this data is being filled up. So when we are taking the data, it doesn't take it from the bottom. So we won't consider for the product. And this is being considered from the top. And from the top, if it is the first data to come out. So stack process is called as last in, first out, or we can name it as first in, last out. This is the first in which is coming out at the last. This is the process which we go ahead with the stack. So here in a stack, when we are going for 8085 microprocessor, the top of the stack address is been given. The stack address is been given by a stack pointer, which is a 16-bit register. 16-bit register named as what? Stack pointer. So this stack pointer, what it does is that this stack pointer would be loaded with one value. Let's take LXI SPFFs. This is stack pointer. So the top of the stack is nothing but FF. So when you are storing the data, what happens is that it will decrement with FFFE. It will decrement and store the data. It will decrement FFFD. It will decrement and store the data. It will decrement, it will store the data. Decrement. As you go on over here, it will decrement the data. And when we are collecting a data, so this data has been collected. So after collecting the data, it will increment the memory location, increment. So when you are storing the data, what we are doing? Decrementing the memory location. After one data is been stored in FFFE location, then we'll go for decrement the data value. Then we decrement the data value. We'll collect the value and decrement. Collect the value, decrement. Collect the value, decrement. So this is a backward direction. And when we are collecting it up from the stack into the someone. So this is with the first, then increment the memory, increment, then last comes is FF, then it will start. So again, this is one sort of data how it stores and retrieves in the stack. Then how this is been possible? How you want to store a data into the stack? To store a data into the stack, we had one instruction called as push instruction. Push instruction is used to store a data into the stack. And when a data is being stored into the stack, if you want to take the data from the stack, we'll go for pop instruction. These two instructions are used to store a data into the stack or retrieve a data into the stack. This is for your requirement. But sometimes the data which is not being, you are not wanted to stay into the stack, but unavoidably this data, some data would be stored into the stack. Then what is this kind of data? We called it as. So whenever you go for a call instruction, whenever we go for a call instruction, so that the call instruction we are having an memory process 2000 we have given a call instruction. At 2003, the next instruction has to be executed. But this instruction is not getting executed. So what happens is that this instruction address is being taken in and put into the stack. This 2003 is being kept in the stack. Until what period? Until this call, whenever you go for a call, there in that call you will be finding one return. Okay, in the call program you will be having one return. So when we go for return, what happens is that whatever the program it is been executing, it will stop that one. Once it's written, it will go to the stack. So whatever the value over into the stack, it will take and it will load into the program counter. What is that? Program counter, PC register, into the program counter, and this value is being would be the new value for the stack, and it would be to say that would be the value for the main program to execute. So this is the another use of a stack. So here, for example, we are going for a push B. What is that instruction we have given? Push B. So this is a one simple 1 byte instruction. So push B will have B and C register pair. So first it will it decrements the stack pointer by 1. Decrement the stack pointer by 1. So stack pointer was at FF, it will decrement FFE. So it will load the B value, B register value. What is the B register value? 1, 2 is being loaded over here. Then again it will decrement the stack pointer by 1. Okay. Here it is 1, here it is 1. Stack pointer by 1, and it loads the second byte, which is there nothing but F3. This is the example over here. Now when this is the push operation. Now when you go for pop, we are going for pop instruction with D. So D register will have two registers. One is a D register, the other one is a E register. Pop D and E. So what happens is that first, previously it has decremented the memory location and stored the value. But here first what it does is that it takes this value, store it into the E register first of all. Then it will increment, add 1 to the previous value of the memory location. Memory location value was FFFFD, added 1 to this one, FFFE and D. This is the memory location. It will go to this memory location, then it will take the byte over there and it will copy into the D. This is because when we have given the instruction called as pop D. Suppose if I have given again at the push I have given push B and I have given pop B, then what happens? So whatever the value we are going to give the stack, it is collected back again into the B register, B and C. First location it will load into the C, second location value it will load into the B. So this is about the concept of a stack. These are the two instructions related to the stacks, push and pop. Push is loading a value into the stack. Pop is collecting a value from the stack. Once we discuss about the push and pop, we will be having another type of instructions which would be using a stack, like storing the addresses. Overall here, stack is a very important memory device which is used to store the temporary data. Thank you. And the remaining next part of the videos, you can watch it on my channel. Thank you.